Hello, everyone. Mr. Minnick is my name. Math is my game. Today I'm joined with my favorite Algebra 2 class ever. This is that fair to play favorites like that? Okay. Okay, so what we're doing is we're looking at Chapter 4, Section 7, Part 2. Part 2. So this is actually the part that the other classes haven't seen yet. And what it's all about is a compound word, a word that's made up of three words. If you think about a circle or a plate, or something that somebody throws in in track and field, that's not the shot put, that's not a hammer, that's not a javelin, and you take the us out of it. It's disc. So D-I-S-C, disc. The next word is something that I used to pride myself on being able to jump up and grab a hold of. Now, if I tried, I'd probably damage my knees for the rest of my life. But I used to be able to jump up and grab the rim quite readily with both hands behind the back from about 20 feet away. Well, not 20 feet away. That's exaggerating a little bit. But I used to be able to grab the rim quite handily. If anyone thinks that they can grab the rim, a good part of it, they should be able to jump up and touch the ceiling in this room, because the ceiling in here is about 10'2". I used to be able to palm it, both hands, my first couple years here. Not so much anymore. I put on about 40 pounds since then, and I've aged about 11 or 12 years also. So the discrim, actually there's four words. The next word is the opposite of out, in. And then the last word is what crawls on your countertop in the summertime. Ant. So it's called the discriminant, and a lot of people have misconceptions about it. They say, I don't know what it is. It's because they don't write it down in their notes. I didn't know how to find the discriminant. It's because you didn't jot down the formula in your notes. I didn't know what to do with it once I did find it. It's because you didn't write down the rest of it. So there's going to be a formula to it. You are going to be expected to calculate it, and you are going to be expected to interpret it. It's kind of like Spanish. Consider these. 1, 2, 3, 4, 5. Right? That's in English. The numbers 1, 2, 3, 4, 5. In Spanish, they are uno, dos, tres. How do you spell cuatro? I always put a Q in it. Is it a C? Cuatro. Like that? Cuatro. Cinco, right? So not only are you expected to know them, you're expected to know what they mean. Well, it's the same idea with the discriminant. You're expected to know what it is, how to calculate it, and what it means. So the discriminant is simply the radicand from the something something. So from the something something. It's the radicand from the something something. Now, in this particular class, we haven't officially talked about the something something, but I guess I bet I could that some people in here could guess what that is. The quadratic formula. Yeah, it's the radicand from the quadratic formulae. From the quadratic formula. Hold on a minute, Mr. Minnick. You just used a word I don't understand. What the heck does radicand mean? The number under the radical. Thank you. Yeah. So I guess we have to look at the quadratic formula. So it's x. I'm not going to sing the song. Equals negative b plus or minus square root. It's actually easier to memorize if you sing it like that. Did anybody ever hear that video? So what we're saying is it's really just b squared minus 4ac. That's all it is. That's what the discriminant is. It is going to be a number because we are going to substitute and we are going to find some things. So what we're saying is the discriminant. How do you find it? Well, it's calculated by taking b squared minus 4ac. That's the formula for it. The discriminant is calculated in that fashion. It's actually quite simple to find. Question, comment? It says negative b. So in the quadratic formula there is, let me get out my magic marker to draw attention to some things. There is a negative b out front here, but under the radicand it's b squared, and in the discriminant it's the same thing. Remember the discriminant is the radicand from the quadratic formula. Okay, so in the quadratic formula we do have a negative b out front, and then it's a b squared under the radicand. I don't know if that answers your question. I'm sorry? Okay, good. Cool. How's everybody doing so far, okay? Another question, comment. So at this point in time, I'd like to open up the forum for shout-outs. Does anyone want to give a shout-out to somebody in another class? Chandler Stefanik gets a shout-out. Kelly File gets a shout-out. And Matt Reeser gets a shout-out. Calvin Kohler gets a shout-out. How about the future Mr. Minnick? Mr. Minnick loves to get future shout-outs. So here we go. Example 1. Find the discriminant. X squared plus 6x plus 9 equals 0. Now, one thing we do have to realize, and we're making a big assumption here, and I think you have all seen the illustration of what happens if you assume things. So I'm not going to go through that. But we do need to have the quadratic equation in that form that you don't want the abbreviation to, in standard form. Does anybody remember how standard form goes? It's A, not times a group of, it's just A x squared plus bx plus c. And if we're talking about an equation, all that is equal to 0. Good, great, awesome. So our equation is in the right form, isn't it? So let's identify our b value. There's a reason I skipped over a. Our b value is what? 6, great. And the c is 9. Now, a lot of people have trouble identifying a. I take for granted that people understand what it means for something to be implicit. In other words, it's implied that it's there. It's not written. It's not clearly stated, but we know that it's there. We can assume it's there because it is there, but it's not. That's so weird. What's our a value? It is 1. It's the coefficient of x squared. It's not written, but it is out front there. Okay? So our a value, believe it or not, it really is that 1 that's out front. And some people say, well, how come it's not 0? If it were 0, that quadratic term would go away. And hopefully you remember that from when we talked about 4.1. So our a value is 1. How's everybody doing so far? Okay? Good. So the discriminant, when we calculate it, the discriminant, I think it's kind of confusing if we call it just D. And maybe we could call it big D, but that would kind of be offensive in some context. So we're not going to call it that. So it's calculated by taking b squared minus 4ac. So that's going to be 6 squared minus 4 times what? Times 1 times 9. Okay. So then it's, what's 6 squared? You sure it's not 12? A lot of people think it's 12. If a lot of people think it's 12, it's got to be 12, right? Because it's 6 times 2? Oh, it's 6 times 6, so it is 36. You're right. Now, I mentioned yesterday that some people will mess this up. We're taking negative 4, we're multiplying negative 4 by 1, and we're multiplying that by 9. Altogether, that's going to be what? Minus 36. Okay, and 36 minus 36 is 0. Okay. That was easy, wasn't it? Okay. So the question is, do you have to plug it into the rest? Well, if we look at our directions, the directions kind of tell us what to do. It just says find the discriminant, and we did. It's 0. Question. What do we need the discriminant for? Terrific question. Best question I've heard all week. Long distance high five. Good. So what does it tell us? It tells us one of 3 things. If the discriminant equals 0, then so I heard somebody say there's no real solutions. You got the right idea, but if the discriminant equals 0, wouldn't we have to kind of disregard the plus or minus? And if we disregard the plus or minus, then there's not going to be two solutions. There's just going to be one. But to make it so there is two solutions, it's the same solution twice. So what we'll say is, if it's 0, if the discriminant's 0, then there is one repeated solution. Now, sometimes we're talking about functions, and if we're talking about functions, we're not talking about solutions of functions. We're talking about what of functions? Anybody remember the synonyms we called those things? There were a whole bunch of different words. If it's a function, if we're dealing with functions, it's going to be one. If we're dealing with a function, we don't call them solutions. We call them the point where the graph crosses the x-axis, x-intercepts, or there was another four-letter Z word, 0, or another four-letter R word, root. Okay, so if we're talking about an equation, there's one repeated solution. If we're talking about a function, there's one repeated x-intercept, one repeated 0, one repeated root. Okay, is everybody all right so far? Okay. Well, I did say that there's three contingencies here. If it's not equal to 0, then what else could it be? It could be less than 0. But let's not worry about that one just yet. Let's suppose that it's positive. If it's positive, then we do have to account for the plus or minus, right? And if we account for the plus or minus, then there are not one, but two real solutions. Okay? And again, keep in mind that's referring to equations. If we're dealing with functions, we would be talking about x-intercepts, okay? Or zeros, or roots, if we're talking about a function, okay? Now, why is that the case? Yeah. Why is that the case that if we have something positive under a square root that there's going to be two real ones? Well, because it is going to be real. You got the third idea? What's the third one going to be? If b squared minus 4ac is less than 0, then there are, or what? We got to be careful how we say this. Somebody said no solutions. You're right if you're in Algebra 1, but we're in varsity math. There's no real solution, and we could take that a step further. There's no real solution, but there's a big but here, and it's going to be a big but with just one T, not with two. But there are two. Let's think about the opposite of real in terms of the number system. Not irrational, imaginary. There we go. Two imaginary solutions. Okay. And again, the same thing applies to functions. If we're talking about functions, the function's not going to have any x-intercepts. The function will not cross the x-axis. What do we think? We're gonna look at example 2, where we will find the discriminant so that we can determine how many zeros a function has. Sound like a winner? Okay. So let me leave this up here for a minute. Yeah, my mic cable gets tangled up all the time. Yeah, it likes to twist up. Everybody all right so far? Here goes example 2 then. Example 2. Find the discriminant to determine the, and I'm going to use a word here that really trips people up. to determine the nature of the roots of f of x. For f of x equals negative 2x squared minus 5. This will be good. So there's a word there that's kind of confusing, but if we don't know anything else, the calculator, the directions say find the discriminant, right? So that's a good starting point. So let's find the discriminant. What's our a value? Negative 2. Let's see what our c value is. We got to be careful. If you use the wrong a value or the b value or the c value, something's going to get screwed up here. I heard two different answers, so let's be clear about what c is. C is negative 5. If you mess up an SIGN sign there, it is going to throw off what you're going to get. So this might seem very menial or like a minimal task, but it is an important task. We got a comment or a question? B is not 1 in this case. B is 0. If there were a linear term written in here, it would be plus 0x. So consequently, the b value here is 0. Okay. So again, it's not safe for me to assume that everybody knows that. And so yeah, we do have to identify these things right. Okay. Everybody good so far? Okay. So the discriminant, if you remember, the formula was b squared minus 4ac. So that's going to be 0 squared. Now, at this point, will we say no solution? No, we're not solving anything. We're calculating the discriminant, and we haven't done it yet. Yeah, what are we going to get? Minus 4 times negative 2 times negative 5. Holy moly. What's up with all the negatives? What's 0 squared going to be? 0. What's the product of 3 negatives going to be? Positive or negative? It is going to be negative. 4 times 2 is 8, and 8 times 5 is 40. So we get 0 minus 40, which is minus 40, or 40 below. That's cold. At least we didn't get 50 inches of snow. Not yet. It's coming. So the question asks us to not only find the discriminant, find it so that we can determine the nature. What's that mean, the nature of? Not where it comes from. The nature of the roots. Not its purpose, the nature of its roots. Where it began or started? No. In this context, the word nature means something totally different. Conclusion, we're kind of onto something there, but the nature of the roots. Maybe we ought to go to Miriam. Maybe Miriam could help us. I love Miriam. Merriam-Webster.com. Here we go. I wonder if we could put in the nature of. The nature of. Okay, let's try it in the thesaurus. Really? Nature. Dictionary. Nature faker. Nature is the physical world and everything in it. It's the natural forces that control what happens in the world. It's the way a person or animal behaves. The character, here we go, the character or personality of a person or something. The inherent character or basic constitution of. So we're kind of onto something. We're looking more for the definition that says the character, personality, or trait. What traits would the zeros have? What kind of zeros would we have? Let's think about the graph for a second. If we were to graph that function, would it not be a parabola that opens down? And would its vertex not be at 0, -5? So the graph of it's going to look like that, right? So how many zeros does it have? Well, maybe we need to go back a page. If the discriminant is negative, then there are no real solutions. I forgot the S in solutions. There's no real solutions, but we're not talking about solving equations. We're talking about the function. So what do we say about this function? No real solutions. We're not solving. No. The function has no x-intercepts. The function has no x-intercepts, or no real x-intercepts. Okay? The function has no real x-intercepts. That's what we would say. So it's weird how one word that we think we know can really screw us up in the context if we haven't seen it in that context, isn't it? It's kind of confusing because everybody thinks they know what nature means, but nature in this context just means what kind of roots are they? Are they real? Are there two of them? Are there one of them? Are they not real? Don't they exist? Okay, let's try one more of these. If it were positive, there would be two real x-intercepts, and that would be it. Right. Right. And if it's 0, then there's 1. Yeah. So let's try example 3. Example 3, determine how many and what type of solutions x squared plus 4x equals -6 has. Wait a minute. I want to phrase this right. How many and what type of solutions? Yeah, that equation has. Okay. So we got to identify A and B and C, huh? So it's our A value. A is 1. B, 4, and C, -6. Oh, wait a minute. Hold on a minute. Wait a minute, Mr. Postman. So to put it in the standard form, we'd have to have x squared, got it, plus 4x, got it, and add 6, so it'd be plus 6. Okay. So the C value is 6 then. All right. So B squared minus 4AC would be 4 squared minus 4 times 1 times 6. So that's going to be 16 minus 24. So that's -8, and because it's less than 0, what do we say? No real solution. Are there two solutions, though? There are two imaginary solutions, right? So there are going to be two imaginary solutions. Do we need to try one more, or do we got the idea? I think we might want to try one more. One more. Last one, I guarantee it. Okay, last one, I guarantee it. Last one. What if we had -4x squared minus 19x plus 18? This is going to be good review for the perfect squares too. Okay. So let's see. What's the formula? B squared minus 4AC. So what's my B value? My B value is I'm hearing people say 19, and it's not 19. It's -19, and a lot of people are going to do that. And a lot of people don't remember the perfect squares, so they're going to use the calculator. And you know, there's nothing wrong with using calculators. There's nothing wrong with using a Corvette. There's nothing wrong with using a 110 horsepower chainsaw if you know how to use it. But if you don't know how to use it, you could get in a lot of trouble. And the calculator is the same way. The exact same idea, the same principle, the same general thing. So once my calculator decides to cooperate, here it is. There it is. Let me try to square -19 on my calculator and see exactly what it says about that. If I'm going to cut my leg off or not. I've actually cut myself really bad with a saw. Not a pleasant experience, let me tell you. So -19 squared gives me -361. So I reckon this should be -361, right? Oh, I got to put it in parentheses because no matter what, if I square anything, it's going to become positive, right? But the calculator said it's negative. The calculator's wrong. I didn't use it right. So anyway, yeah, so we are going to get 361 and then something. So minus 4 times A, so times negative 4 times C, which is 18. Okay. So I have a negative times a negative. Is that going to be minus or plus something? It is going to be plus something, and I could care less. It's plus something. And so at this point, I realize it's going to be positive. It's going to be positive. So what kind of solutions am I going to expect? 1, 2, or none? 2, what kind? 2 real solutions. Everybody all right with that? If we were to graph the related equation, or the related function, I mean, if we graph negative 4x squared minus 19x plus 18, I said plus 18, I didn't write it, but plus 18, how many times should this graph go through the x-axis? It should go through twice. Let's make sure it does. Bam, bam, like a mouse. What happens if I change all the signs and I make this positive 4x squared and I make this plus 19x and then I make this minus 18? Do you think it's still going to go through the x-axis twice? Let's find out. Because sometimes maybe you put the equation in standard form different. Let's see what happens. There's once, there's twice. Did it go through in the same spots? Hold on a minute. Did it go through in the same spots? Holy moly, it did. That's interesting. Hopefully, that explains to you why when we divided out the A value when solving equations, the A could kind of just miraculously go away. Anyway, so that's it. It's been fun. Are there any more shout-outs? Future Mr. Minnick again. Thank you. Appreciate that. Anybody else? All right. Well, that's it. I'll see everybody next time.